question 3D of the paper. It's a circle geometry question. So it's a series of questions asking us to show that there's a cyclic quadrilateral and to further show other things. Okay, so the first part of the questions asks us to show that QKTM is a cyclic quadrilateral. So if we take a look at it here, QKTM is this thing, so it's QKTM. Okay, so we're given various information. So on the diagram, which you can look up online or something, it has this circle, so it's got a right angle here, and a series of lines joining stuff, and also a tangent MN. Okay, so for the first part, we need to show that QKTM is a cyclic quadrilateral. So there are various ways to show that there is a cyclic quadrilateral, but the most obvious one here is that there is a 90-degree angle here and a 90-degree angle here. So this is actually the theorem that the exterior opposite angle is equal to the opposite interior angle of a cyclic quadrilateral. So since these two are true, we can say safely that QKTM is a cyclic quadrilateral. Okay, so the next part. Show that angle KMT is equal to KQT. Okay, so that's KQT is this angle here, and KMT is this angle here. Okay, so one property of a cyclic quadrilateral, as you should know, is that since KQTM is cyclic, a circle lies on KQTM. So that must mean that this angle and this angle are the same since they are standing on the same chord. So if you imagine there is a circle here that houses these 4 points. It's not a very good circle, but it will do. So as you can see, same chord or arc, and since these angles are subtended from the same arc, they must be equal. So we have shown that KMT is equal to KQT. Hence or otherwise, show that line MK is parallel to TP. Okay, so this is the last step. So obviously we're going to be using I and II. So since we know that these two angles are the same, let's consider the bigger circle, TPQ. And since this is a tangent, one thing you should think is that the tangent and the angle that a chord and a tangent make will be equal to the angle in the alternate segment. So if we look here, this angle here, since it is the tangent and the chord, is equal to the angle in the alternate segment, which is this angle here, PQT. But already we've shown that in part I that these two angles are the same. So if this angle is equal to that angle and that angle is equal to that angle, then these two angles must be the same. And since these are all straight lines, these two are corresponding angles that are equal. Thus, these two lines must be parallel. KM is parallel to PT, and you're done.